When determining horn sound output level versus distance that can be covered, there's several factors that you need to consider. First of all, the mounting height of the horn. Let this line represent the mounting height. Let's say this is 20 feet in our example. And we're not interested in what the sound level is 20 feet below, because that would be right on the floor. We designed for a distance that's 5 feet above the floor. We'll draw a line here to represent that. Okay. So from this distance, 20 feet above the floor or 15 feet above the listeners, we mount a horn. And there are two sound levels that you're concerned with. The first sound level is going to be directly below the horn. This sound level is referred to as our maximum dBSPL over ambient, and we designed for this level to be no more than 20.86 dBSPL over the ambient noise level. We do that by determining the horn output level and subtracting from that the loss along this distance. In this case, it would be the loss along 15 feet. And we designed so that this is no more than 26.86 dBSPL over the ambient. The reason we add 6 dB is because at the dispersion angle, as you move the horn out, you're going to lose 6 dB. So the net result would be no more than 20.86 dBSPL over the ambient. The next sound level that we're concerned with is the angled distance sound level along this line of sight distance. If you take the horn output and subtract the loss along this distance, the net result should be that you have no less than 6 dBSPL over the ambient at this angled distance. And again, this is at 5 feet above the floor. By doing this, nowhere in the room will you have more than 20.86 dBSPL over the ambient, and nowhere in the room will you have less than 6 dBSPL over the ambient. Now, relating this to sound design, notice that we calculate at 5 feet above the floor, and this is designing for a horn mounted 18 feet high with a 4-foot reference dB level of 94.84689 dBSPL. Well, if you're 18 feet above the floor, then you're actually designing for 18 minus 5 or 13 feet of loss. So if you take this sound level and you determine the loss at 13 feet, the level that occurs here should be no more than 26.86 dBSPL over the ambient. Well, in this example, we're actually using 60 dBSPL. The loss along 13 feet of distance would be 20 times the log of 13 over 4, which is our reference distance. So if you take 13 and divide it by 4, take the log of that and multiply that times 20, that will give you our loss along that distance. So along 13 feet, we're going to lose 10.23766721958 dBSPL. Now remember in our example that the horn was turned up to 94.84689 dBSPL at 4 feet. I'm going to round that off a little bit and enter that into our calculator here. We'll just say it's 94.84 dBSPL at 4 feet. And we're going to subtract from that our loss along the 13-foot distance. We'll round that off also to 10.23 dBSPL, which means the sound level that would occur at 5 feet above the floor is 84.61 dBSPL. Notice that if we're designing for a 60 dB area, this would be 24.61 dB above the ambient, which would be acceptable for our maximum value. Now let's go through option A, pressing enter. I'm going to put in a room that's 160 by 220, and we'll use that 18-foot mounting height and 60 dBSPL. Notice that this number, 24.61, added to the ambient noise level of 60 dBSPL, would be 84.61. That's exactly what we calculated here. That's how we determine the maximum dBSPL over ambient. Notice that the program has calculated that the line of sight distance is 110.77 feet. Once again, determining the loss along that 110.77 feet, we take 110.77 and divide that by our reference distance of 4 feet. Take the log of that and multiply by 20. The loss along that distance is 28.847 dBSPL. Now if we take the horn output level that was determined by the program, which if you recall was 94.84 dBSPL at 4 feet, and subtract from that the loss along the line of sight distance, which is 28.84 dBSPL, you'll notice that you have exactly 66 dBSPL. This is 6 dB above the ambient noise level of 60 dBSPL. That's where those numbers come from.